Back to our chapter, and today we start our chapter in proper manner. We had a casual discussion. So, children who are following the new syllabus, you will have this chapter, and children who are following the old syllabus also, you will have this as a part of a chapter. So, we will not go chapter wise, we will go topic wise, so that old syllabus children as well as new syllabus children both get benefited. Okay. So, our topic, which will be as force and pressure in many other textbook, in some books it will be exploring forces, some book will say about force. So, we should be able to know everything about force. That is a part of our curriculum in grade 8. Understood? Chale. So, in order to understand force and in order to define force properly, so we again go back to our same old story, that if you have, in physics, you will hear this word a lot, body. What is a body? A body is something which has got a mass and has got a shape. All right, we have a body, and say we also have a person beside the body. Okay, this is another person. So in physics, we can call this as body 1, and we can also call this as body 2. So these are two bodies, right? Pay attention now. Okay, if there is an interaction between these two bodies, a force can be experienced either by this body or by this body. That depends. But if there is no interaction, then neither of the body experiences any type of force. Is that clear? Let's think about yourself. You can pull a spring towards yourself. You can pull a spring towards yourself. Equally, the spring also experiences a force that it wants to contract back. You can lift an object. You are applying a force. You can twist an object. Twist, twist. So something we call, like say, suppose, have you heard the word called shearing? Have you heard the word called torsion? Torsion is something where you hold something and try to rotate it. It will break. We call it the torsional force. So if you give torsion, then also it will break. So if there are two bodies and there is an interaction between these two bodies, we can expect force to be, force is what do you call, the phenomenon of force can be exhibited by an interaction between these two bodies. So it first comes that in order to understand force, we should first understand what is the meaning of the word interaction when you talk in terms of physics. It's an effect. It's an effect of a body on another. Or see, it is like I never say what you write and what you not. Now you are getting up from 8 to 9 to 10. If you feel that there is something substantial you are getting to know, you write. These are class notes. End of the day, what we discuss, I write. Doesn't mean that you write without understanding. End of the day, you should go back, read your textbook, and you should be thorough with your content. Okay. So a force is an interaction. An interaction is an effect of a body on another or vice versa, and will create some impact, and that impact can be some sort of a change. Okay. On one another. So let's try to understand. Interaction means, in order for interaction to happen, you should have minimum two bodies. Okay, minimum two bodies, body 1 and body 2. What does interaction mean? Interaction means there is some effect of B1 on B2 or B2 on B1, effect of B1 on B2 or vice versa, that is B2 on B1, which will create some impact on one another. And these impact can be some changes. Yeah. We'll come to that. So B1 and B2, you can have some sort of an interaction between them. So we need to understand the word interactions from the perspective of physics. So we say that there will be an effect of B1 on B2. That can be, now we are trying to learn force. Now see, this force is an outcome of an interaction. So when we talk about force, a force is an outcome of an interaction. A force is an outcome of an interaction between two bodies, right? Unless and until there is an interaction, there won't be any force which will come out as an outcome. Look at these two body 1 and body 2. If there is no sort of interaction, you don't expect any force either to be felt by B1 or to be felt by B2. However, if we say that this body is trying to say push this body, or if this body is trying to pull this body, then there is an interaction. There is now an interaction between the two bodies, as a result of which the outcome will be force. And that's why we say force is the push or pull. Force is the push or pull that acts on a body. Whether you lift it, in that case also you're pulling something. Whether you drop something down, in that case also you're pushing. Push and pull is an easy way of understanding force. So let's get little bit detail and get the cloud removed. In order for force to be experienced, or in order to see the impact of force, something that we cannot see, we can only see the impact of force. You don't see force. You see the changes that are created by force, or the outcome that are done by force, or the effects of force. For that, you need to have two bodies, and there has to be an interaction between the two bodies. What do you mean by interaction, sir? Interaction means an effect of one body over the other, one body pushing the other, pulling the other, in such a way that they will create some impact on one another. That is called an interaction. दो चीजों के बीच में कुछ ना कुछ interaction तो होना है. Interaction होगा तो ही force outcome में आएगा. Acha, how to study? Like I'm giving you, we are discussing something. I'm writing some class notes. They may tally with your books, they may not tally. A good student, how he will study this, you know, they will go through this, they'll go through video until the section that I have taught. They will now consult their books, because end of the day, it's your textbook, which is more important. And they will prepare one nice copy where they'll start making their own notes in colorful manner. Sir spoke about force. Is everything clear for force for me? Is everything clear in terms of interaction? Okay? That is how you study. And another way to study is you pay attention in my class. Once the class ends, close your books, put it in back, go back, and next day again come to my class. If you are coming next day to the class without any study, without any plan, without any to-do list, that is as good as not coming, because you are not planned. ये class आने से पहले you should go. Now it's very start of the classes, but as we go higher and higher in maths and we study new topics, you should come with your work done. Sir, I studied and these are the points which I did not understand about. Right? So force is an outcome of an interaction between two bodies. Unless and until there are two bodies, you will not see force as an outcome. And for a pretty simple level of definition, we say a force is a push or a pull that acts on an object. Push or a pull that acts on an object. What is the object in that case? Body 1. Body 1 is experiencing either a push, or body 1 is experiencing either a pull. Is this understood? Okay. Let's see a little bit more. Okay. Now say suppose we have a person, okay, and this person is trying to push another body, right? Is trying to push another body, right? And he is applying, or he or she, whatever, is applying a force. Another way of defining force. A force is the outcome of an interaction between two bodies. Now look at the definition. Here the definition, and see the graphics also. A force is an outcome of the interaction between two bodies. This is my body B1 and this is my body B2, which, if not opposed, what do you mean to oppose? Oppose means you give another force directly in opposite direction. Let's oppose it. Let's oppose this with another force. If this force was not there, what do you expect this body? It will move. So let's eliminate that force and now try to define. A force is an interaction between two bodies, which, if unopposed, will create a motion on the other. And that motion has been created by what? By push, you can say. A force, whenever a body experiences a force, okay, so we can write it like this. A force, rather than only saying a push and pull, let's be a little bit more mature in our definition. We say a force is an outcome of an interaction between two bodies which, if not opposed, will create. Now, I'm not saying only will move. Now, see how we will debate. It's not about only move. Will create a change in the state of motion of another body. And in grade 9, you will be learning about Newton's laws. And then this becomes very important. Let's understand this. Now, my example said that this body was at rest and you are trying to push it and you are allowing your push not to be opposed. So what do you see? It goes into motion. Let's see an opposite thing. Let's see another scenario, okay? Let's see another scenario. 1 minute. Let's say another scenario, okay? Here is a person who is applying a force to a trolley. The trolley is moving. In this case, this was stationary. It begins to move. In this case, the trolley is moving. Now, if you don't give an unopposed force, the trolley continues to move. And if you oppose it, the trolley stops. There is where this definition says, it doesn't say that it will only bring into motion, it will create a change in the state of motion of another body. Means if you are moving, you can be brought to rest if I oppose. And if you were not moving, you can be brought to motion if I don't oppose. Are you understanding? So there are two bodies. Just understand there is an interaction. Now we will, no need of memorizing these definitions. Try to understand. There is an interaction. Here also there is an interaction. There is an interaction. As a result of this interaction, force will be created. Now this force is a push force. Here also a push force has been created. Here the body was at rest. If you don't oppose, this body will go into motion. And if you oppose this, not with a feeble force, with an equal force, this body which was in motion will come to rest. In grade 9, when you learn about Newton's laws, you learn this only. A body in rest remains in rest. So that's okay. So our idea is, what you should understand is, a force is an outcome between two bodies. An outcome due to an interaction, which may create a push or a pull. All forces can be finally classified into a push or a pull, right? Because the other body will be experiencing either a push or a pull. That depends upon the first body. If the body is moving away from the first body, we say it's experiencing a push. If it is moving towards this body, we say it is experiencing a pull, right? And if you don't oppose this outcome, if you don't oppose force, then force will always create a change in the state of motion. So a football, right? Look here. So we have a guy out here, and say suppose there is a football out here, lying idle. Nothing happens. Once you actually put a force with a kick, the state of motion of this changes. The ball was at rest and the ball immediately starts to go in motion. Yes. Yes. Yeah, please. You can go in this room. You can go in this room. Yeah. The switch is inside, huh? So, yeah. Yeah.
So what are the opposite forces?
That we will see later. That we will see later. Force can be less or more. In that case, we will see what happens between interaction. But out here, our main idea was to understand what is force. As a very preliminary level, we say force is the push or pull that is acting on an object. To go a little bit in higher level, we say a force is an outcome due to the interaction between two bodies. And that outcome is a force. If you don't oppose it, there will be a change in the state of motion. At least this much. Have we understood now, right? And whether it is more or less, whether we oppose more or oppose less, that we will see later on. Is this much clear? Right? Let him come. So based on our discussion so far, slowly we will go. Our discussion so far, we can create a mind map. In order to force to happen, we should have, see, you can create mind map and yourself study. We should have an interaction. Such interaction can be possible between at least two bodies, body B1 and B2, right? And you get force, and then you can, this force can cause a change in the state of motion, can cause a change in the state of motion. So either you can be at rest, or you can be brought to rest, or you can be. Is this understood? Right? So once we have understood force, we should understand some more things. Force is, in physics, everything we study is known as physical quantity. Force is a physical quantity. Physical quantities in physics are further classified, this is a little bit grade 9, are further classified under two states. One is known as scalars, the other is known as vectors. Any physical quantity. So what are physical quantities? It can be temperature, it can be density, it can be mass, it can be force, it can be electric current, it can be magnetism. Any physical quantity can be classified, as generally classified, either into the scalar family or into the vector family. So we should understand now what are scalars and what are vectors. Okay, scalars. If you have a quantity that can be expressed only by magnitude. Now we have to understand the meaning of the word magnitude also. Magnitude means a sort of a value, Any physical quantity which you express only by magnitude. Say length. What is the length of your television screen? 75 inches. I don't need anything more than that. Only by magnitude. Okay. What is the height of this particular body? So much. What is the temperature today? 36 degrees Celsius. How much current is flowing into this house? We will say 2 amperes. Right? Quantities which are expressed only by magnitude, those quantities are known as scalar. Now you start asking yourself about force. Say suppose, very nice example. I say, please apply a force of, say, whatever, 5, 6 on this table. Your next question to me would be, sir, do I pull the table or do I push the table? Otherwise, if you are a robot, you'll be hanging for the next command. So we say that quantity that need both magnitude, that means a value, and direction, are called vectors. Any physical quantity which, when you define, you need to specify direction, then that physical quantity belongs to the Khandan or the dynasty of vectors. Now ask yourself, what should be force? Force should be a vector, because force cannot be defined only by its value. Unless and until I say which direction the force has to act, can you actually tell about force? You can't. Is this getting clear now? Why force? And say suppose we can put some examples also if you want. Okay, let's put some example. Here example would be length. Okay, time. What is the time now? The time now is 5:55. Do you say 5:55 east, 5:55 west? No, not required. Example is, the easiest vector to understand is force. So we can now say that please apply a force F and please apply it in the east direction. It can be. Or else we say that there is a body out here, right? Try to pull the body in this direction. You give a pull, and the pull should be at say 30 degree. And which side you are going? If this is east, this is south, this is west, this is north. So we will say a 30 degree pull, a pull of 30 degree in northeast direction. If you just say give a pull, we don't know which side to be pulled. A crane pulling something, which direction do you want to pull? Pull by 30 degrees. Sir, 30 degree where? 30 to this, 30 to this, 30 to this where? 30 degree northeast. So this is your north, this is your east. So 30 degree northeast means you will be pulling in this direction. So force classifies as a vector. So this was a little bit different. It's not only about force. Physical quantities in physics need to be classified either to the scalar family or to the vector family. Sir, which all fall in the scalar family? All those physical quantities which need to be expressed only, which can be expressed only by their magnitude, time, length, right? These are all called scalars. They don't need direction. But quantities which need both magnitude and direction, there are many other quantities which you will not understand now, but for you at your level, force is the easiest one to understand. Clear? Go one step more. Yes. Yes, you can do whatever you want. Our next definition is about force. Our next thing about force is, since force is a physical quantity, whatever we have learned, it's a physical quantity and it is classified in the family of vectors. Now we have to, in science, there is no place for subjective comments. How tasty is the food? Very tasty. I don't know what is very tasty. So when you buy an object or you buy see, when you teach physics, everything, if you buy an article on Amazon, what do you see? You see the rating. The rating is actually a quantitative measure of a subjective feeling. So if you have a 5-star, if you have say 400 5-stars on a particular product, it means the product has a lot of likability among people. But if I would have only said, oh yes, good, yes, good, yes, good. That's why when you go to a restaurant and there is a delay in serving food to you, they sometimes give you a questionnaire to fill up. How did you like our ambience? They'll give you a scale. Have you filled up sometimes? On a scale of 1 to 10, how did you like the ambience? How easy was our parking? How easy did you get your food? On a scale, every time you buy a Decathlon, don't you get 3 circles right at the billing counter? Come on, don't tell me. There will be satisfied, dissatisfied. Some people will give scales because it's the simple story. It's a Roman dialogue that say what gets measured gets improved. My son is doing very good in studies. No. My son is not doing good in studies. No. How do you get to know? Mark sheet. The car is going at a great speed. How do you get to know? Some numbers we want. Science is all about numbers. If you don't get me numbers, there is nothing, no place for lots of good thing, bad thing, or this. Okay. So physical quantity called vectors. So force is a physical quantity and force will be measured. So whenever you measure a physical quantity, you have to give a value and you also have to give something which is known as a unit.
Sir, is it force?
Yes. Abrugja, the unit of force is Newton. And when you write Newton, the N should be, when you write the word Newton, the N should be in smaller case. Smaller case. This is the unit. But when it is expressed, it will be expressed like this. Say 5 Newton. At that time, this will be in uppercase. Did you understand this thing or not? If somebody tells you what is the unit of force, what is the unit of force, then you will say the unit of force is Newton. At that time, N you cannot write capital. When you're using the full word Newton, you write the word with N in smaller case. So I'm writing it, just see, the unit of force is Newton. You are not allowed to write in capital, expressed as capital.
And is the symbol?
So if you say something, a force of 5 newtons, so we can write like this also, see. So for example, we can write a force and we write F of 5 newtons. Now this is when you write it in terms of language, but when we will do a problem out of it, we will write F equal to 5 N Newton. Is this now clear how to write newtons? Have you understood? Okay. Now there is a huge story with units also. There is a huge story with units. I'll stop the discussion here and I'll again go back a little bit with units. It's not done. We stop force here and we go back to units. Units. Units are something which have caused huge catastrophe to people. A NASA's Mars mission completely got wasted, not wasted, damaged, because simple conversion of units was not there. Some of the units that you people might be aware at this level is like you measure length in centimeters. You can measure length in meters. When we are traveling across cities to cities, we are measuring it in kilometers. When we go to US, the same kilometer becomes miles. When we are in a horse race, at that time, the miles also can be furlong. Possible? Right. Now, say you go to a shop out here, you go to a shop. And since we are studying everything in mm and mm, all engineering and everything we study in millimeters. So you would be in your diagram, there would be a nail or a screw size, which is 25 mm. Go next time to any shop and say, एक 25 mm का screw दीजिए तो नहीं है. You are correct. He'll say, carpenter से बात कीजिए. आपको नहीं आता है. He will make sure that you don't know, but you are correct. If you change it and then he will speak to the carpenter and say, साहब को ना 1 इंच का कीला दे दो. 1 inch. They understand like that. Now just see. All of us stay in flats. You must have heard about this thing common in your parents' mouth. Our flat is so much SFT. Square foot. Because you are measuring what? You are measuring area. And how did they measure the area of their house? They measured this in terms of feet, multiplied both, and they got it feet square, and that is called square foot. But in all your problems, you are doing area in what manner? Centimeter square, meter square. Why is this coming up? Go to a cake shop, a very old, good cake shop. They will never sell you cakes in kg, pound. This is happening because of the colonial impact. Our country was once under the British rule, and the British follow a unit system which is known as the FPS system. F stands for foot, P stands for pound, right? And S stands for second to measure time. The FPS system. This is what the British do. All British countries, if you go, everything will be in pounds. If you go to London and you buy vegetables, you'll see everything in pound. If you go to Hong Kong also, you'll see bananas are being sold in pound because Hong Kong was once upon a time a British territory. Are you understanding? And we still follow inches. These are called the FPS system. Go to carpenter. A carpenter never understands what is mm. Bhai sahab, isko na 1300 mm mein. He will straight away say, 48 inch hai. 48 inch mein kaat diyo isko. But he's perfect. He doesn't know Pythagoras theorem. He doesn't know units. But do you see any difference in the 4 pillars? You know everything, you won't be able to do this. He has experience. Not a centimeter this way, that way. Is that understood? So where is he gone? He went to the washroom and he's... Oh, you came back. So I thought you were missing. So you will be seeing 4 things. So the carpenter works on inches, right? Now, we know that we are not allowed to take more than 100 ml liquid in a flight. Whereas if you go to US, this ml won't be there. They will talk in terms of ounce. So it is all a confusion. Are you understanding? Different countries, different unit. It is all a confusion. So much of it, like our speedometers are all what? kmph, kilometers per hour. If you go to US, it's all mph. Very good, miles per hour. I have myself been a victim of that. First time when I drove in US, the US they say that the speed should be 55 mph if nothing is mentioned. 55 miles per hour. Are you understanding? And cars will have 2 type of gauges. You can make it in kilometers per hour or you can make it. So I'm driving at 55. So I'm driving at 55 and I'm habituated to drive at what? In India, how we drive? We drive 55 kilometers per hour. But this is quite less as compared to the 55 miles is a very high speed. A 1.6, very good. 1 mile is roughly 1.6 kilometers. So are you understanding? I'm driving at 55 kilometers in US and all cars are crossing me and they're giving me a face like this. I'm not able to understand why, because I don't think I'm driving slow, because I, as an Indian, I'm habituated to the 55 kilometer. See, today we travel in car, even if the glasses are rolled down and nobody makes you look at the speedometer, if you have slight love for driving, then you can say, yeah, we are going something around 40, 45. You can make out 55. I felt I'm going at 55. And then I look, that car has two type of gauges. It's a digital gauge. So I said, this is displaying 55 kilometer, whereas it should be 55 miles. Means I should go at a much more higher speed. So to create and to kill all these ambiguities, we then develop something called the international system. Yes, sorry. We developed something called the international system. Wherever you are in the world, you are supposed to follow the SI. And SI is a French word. My pronunciation may be wrong. It's written like System International Day Unites. I mean, you can correct me. So it is a standard system now that is followed all across the globe. And in SI system, just for your knowledge, whenever you will measure length, you will measure it in meters. Whenever you measure mass, you will measure it in kg. And whenever you measure time, you will measure it in seconds. These are SI units, right? So if a package is coming on a consignment from Qatar to India, the package label cannot be in foot, cannot be in centimeters, cannot be in inches. It has to be meters. However, for more precision, if the package is a 1 meter by a 1 meter box, it will be mentioned 1000 mm cross 1000 mm, because in 1 meter, these measurements get missed out. It is very precise. 1 meter may be up till here. What about this much? So they will measure it. And every drawing that you get, every drawing, whether of a building or anything, at last it will be written all dimensions in mm. No ambiguity. So when you go to the what you call shop and you ask something in mm, you are not wrong. It's just that that fellow is following FPS system. Okay. All of us, if you are going on your two-wheeler, okay, or you are going on a car, you must have experienced this. You must have experienced this, that your dad or your mom goes for an inflation of these tires and they will say, piche 36 kar do. 36. 36 is 36 PSI, pound per square inch. Again, British. Gulam hai na hum log, nikla hi nahi humse gulami. Have you seen aircrafts in India? Next time you board an aircraft, and you see the tail of an aircraft, the tail will always have a number, VT7066 or something. VT likha rahega. You know what is VT? Viceroy's territory. British ke gulam hai. The Independence Declaration has that. Why do you play Commonwealth Games? Commonwealth Games are played by all the countries which were under the Union Jack. And all Commonwealth countries drive on the right side steering. Canada has a steering on right side. Why? Canada is a Commonwealth country once under British rule. Entire China has steering on left. Hong Kong has steering on right. Hong Kong is British. India, British. Pakistan, British. Bangladesh, British. All British countries will have. Germany, left. वो कभी British के अंदर नहीं था. ये VT हम आज भी लिखते हैं. लिखना ही नहीं चाहिए. VT stands for Viceroy's territory. You know the Rashtrapati Bhavan? The name of that was Viceroy's house before independence. So it's Viceroy's state. So now we follow what? SI units. So ये सब बातें होती रहेंगी अपनी जगह पे. हाँ. Pound per square inch. अगली बार go and open the front door of your car. Open the front door. Physics is all about saying go and open. Which door you have to open? Front door. And once you open the front door, this is the front door of the car. Like this. So here you will have the door lock, small socket will be there. When you open the door will open out this side. Here there will be a sticker. Every car will have. how much inflation you should do. There you will see units like bar, PSI, kg per centimeter square, Pascal, everything written. Yeah, driver's seat. Once you open the driver's seat and you have opened the driver's seat, now the door has come this side. On this panel, there will be a small square-like metallic plate where the lock actually goes in. There will be a small sticker, and they will tell you how much inflation you should do on the car. And it will be mentioned either there or on the door. It will be there. It has to be there. That's the international thing. There they will mention many values. But what we follow is the PSI value. Tomorrow, if you go, it's not that you can't change it. All you have to do is that go to that pump set and change the units and make it to say kg force per cm square. And then you read how much your car has said, say 1.2, and then you fill 1.2, you're actually filling 36. But that uneducated guy, he is 1.2 नहीं होता है, मोटरसाइकिल बाइक ना आपका बाइक में 36 जाता. You are correct. 1.2 in the different unit. Understood? Let's give one more example. Water boils at what temperature? 100 degrees centigrade. Right. Very good. On a bad day, you are ill. बच्चों में फीवर कब तक 99.9 के बाद से फीवर आना शुरू हो जाता है, राइट? 101 is fever. A very bad example. 101 पे जब फीवर आ गया, that day why your mom is not heating her tea on your forehead? गैस जलाने की जरूरत ही नहीं है. आपका टेम्परेचर तो 102 हो गया है ना, 102. Very bad, you know. There is a difference. That is 100 Fahrenheit and water boils at 100 Celsius centigrade. There's a huge difference between these two. When you bathe with the geyser water, you must be bathing roughly with maximum 36. 36 also you have to mix water. 40 is very hot. 40 degrees centigrade is much hot. 100 degree though will take away your skin. And can you feel 100 degree? No, you can't feel 100 degree. You feel what maximum sense this skin will get burnt at 36. So anything you touch more than 36, your sense will be the same. I didn't understand that. Okay, so let me give you an example. Look at the interesting in physics. I have a bike whose maximum speed on the speedometer is 100. But I have done some changes in the bike that the bike can go more than 100. ये कांटा कितना दिखाएगा? तो 100 ही दिखाएगा ना? But is the speed of the bike 100? No. So let's say like this. This is you. And you have touched a hot saucepan. How do you feel through your skin? Say your skin will get burnt at 36 degrees Celsius में आपका skin जल जाएगा. And this saucepan is right now at 40. Can you make out any difference? No. 36 में आपका जल जाएगा. You can't say it is a. After that, if I give you 80 degrees saucepan also, you won't sense difference. आपका तो max. You are at your maximum. Your sensory organ is already gone. Your thermometer is already gone. Your thermometer is your skin. This is what maximum heat. Between two heated karhais, say you heat two frying pans, fully heated now. Both are cooking biryani. Can you touch and say what is the temperature difference between two? They're cooking biryani for last 1 hour. Can you touch and say that? No. Because you are operating at your maximum. But you have just put one saucepan for making tea, and one biryani cooking for 1 hour. Now can you say the difference? You can only say this is more hot. Right? So to kill all these problems, we brought something which was known as the international system. Now everything we do in international system, and in international system, we name it as SI. So henceforth, whatever physical quantities we study, like after force, we will study pressure. We have to, sometimes some painting is going on top floor. Can you smell paint? I smell paint. Okay. So we have to talk in terms of SI units. So since our chapter is about force, so we say the SI unit of force. Now, if you remember, I wrote it like this. See, where was it? This after this slide. Yeah, I said the unit of force. So we will add one word here, the SI unit of force. is Newton. Whether you are studying in Germany, whether you are studying in India, whether you are studying in Bandlaguda or you are studying in Birmingham, what is the SI unit of force? Newton, Newton, Newton. So the SI unit of force is newtons. Okay. And it will be expressed as N. Is this clear now? Everything we will be going by SI units. So there is no ambiguity between the way we study and when you do higher studies, if you go abroad also, force will be always studied as Newton. But if you want to have your interest, then we have another system of unit called the CGS system. There are many systems, CGS, MKS, FPS. See how much they used to confuse people. And in our engineering days, we used to get problems in MKS. However, final answer has to be given in SI. So you should know conversions also. CGS full form. CGS stands for length measured in centimeter, mass measured in gram, and S is for time in seconds. MKS is the metric system, length measured in meters, mass measured in kg, and time measured in seconds. So in CGS system, you have a very stylish unit of force. Unit of force is dyne. डायन मत बोलना, डायन तो जंगल में मिलता है, ये डाइन है. Dyne. In many small, dyne is a very small unit of force. In many old books, you will still see dynes. So many dynes. But nowadays, we don't use dyne anymore. We use the word newtons. Is that understood? Even British books will also write pound. If you see some British, what you call National Geographic, somebody narrating in British, they'll say, when a crocodile bites, it will give a force of so many pounds. Because they are British, they go by pounds. So a lot of things we have studied. What all we studied, let's do a quick recap today. So first thing, children, at this level, can we, if somebody tells us, can you define force? We will say, yes, force is the push or pull that acts on an object. Can you be a little bit more elaborative? We say, in order for force to happen or force to be exhibited, an interaction between two bodies is mandatory. Okay, I have given you two bodies. Will there be force? No, there won't be any force unless and until there is an interaction. Once that interaction happens, a force is exhibited. And that force, if unopposed, will create a change in the state of motion of whom? The recipient. Now the word comes recipient. I'm an applicant. I'm applying a force on this trolley and I'm moving in IKEA. And suddenly Uzair comes from the other side. Hey, sir, what are you doing? So he has given an opposing force. What happened to my state of motion? I stopped. And another can be that somebody is wearing a pair of roller skates and like this, and like a naughty person, you just go and push that person. The person was stationary and that person becomes the applicant. No, the recipient, you are the applicant, and it creates a motion in that person. Is it clear now? So you might get MCQ questions where they will ask you, is an interaction, now let's define, make some questions on our own. Is interaction mandatory? Yes, interaction is mandatory. What is the minimum number of bodies you need to see force? Minimum 2. It can be more than that also, right? Just imagine 5 people pulling your hair on either side. It's a 5 plus 1, 6 body interaction. So minimum 2 body. In these 2 bodies, 1 body will be an applicant and 1 body will be a recipient. If the recipient will always show the impact of the force or the effect of the force. And if that effect is not opposed, there will be a change in the state of motion. If the recipient was at rest, he will be in motion. Maybe he is already in motion. Now let's change it. I am pushing the cart in this manner and I am going in IKEA, and this fellow has to take a revenge on me. He comes and pushes me from back. Now what happens to the cart speed? The speed of the cart increases, right? All these things we will study in the next section. Yeah, tell me. Multiple applicants can be there. Multiple recipients may also be there. Tug of war. So many applicants and so many recipients that the entire team is brought this side. Don't you think so? When Ravan's mother used to slap Ravan, then there are 10 faces of Ravan. 1 applicant, 10 recipient. Like this. Just imagine. But one question remains unanswered. When Ravan had fever, by which mouth he used to take dolo? First, second, third, fourth, fifth, sixth. How do you know?
The middle one. Yeah, there is no middle. There is no.
That's also a question. Sometimes think about it. Okay. So now we know, children, for us, important things, interaction. Okay. Then by now you should have understand what you mean by applicant and recipient. Then you also understand change in state of motion. State of motion. This is also something that you have understood now. You also understand what is the SI unit of force. And one extra thing which is not there in your syllabus, that force is mapped to the vector family, because force needs both magnitude and direction to be specified. Now let us see some characteristics of force. Characteristics of force. Rather, what are the effects that force can do? Number one, if a body is at rest, a football is at rest, and you give a force, then what do you expect? The body at rest can be brought to motion. Yes or no? A body which is at rest can be brought to motion. Number two, if the body was already in motion, then you can apply a force. You can apply a force and bring a body which was already in motion. You can bring it to rest. Rest and motion will eat your head like anything in grade 9. If you are already in motion, you can be brought to rest. If you are already in rest, you can be brought to motion. Third, force can change. We'll talk about all this. Speed and direction, either one or both, of a moving body. Speed and direction. Speed and direction. A bowler is bowling an outswinger, batsman just glides the ball and makes it go towards the third man. He has changed the speed as well as direction. Or you hit a six right over the bowler's head. Force can change both speed and direction of a moving body. If you are at rest, you can be brought to motion. If you are at motion, you can be brought to rest. If you are moving, then depending on the direction that the force is applied, it can increase your speed and also change your speed. Rather, I'm saying that means it can decrease your speed or it can increase your speed and change your direction. Fourth, force can also change the shape and size. Force can change shape and size. Have you all played with Play-Doh? The worst thing that has got manufactured as a toy. Horrible, it smells. So all in Play-Doh, what do? You give forces. You can change the shape. You can change the size also. Every day that you make a roti, you're changing the shape and you're changing the... And people say, na, I'll give you one tight slap and I'll change your face. That is also one example of force. एक थप्पड़ से चेहरा बिगाड़ दूंगा. वो भी तो force ही है ना. So force, these questions do come. What are the characteristics of force, or what are the effects of force? What are the effects of force? Force can bring a body from rest to motion. Force can bring a body from rest to motion, or force can bring to rest a body which is already in motion. Force can change the direction and speed of a moving body. Force can also change the shape and size of a body. Now start giving examples. Rest to motion. Kicking a football. Motion to rest, brakes. When you apply force, then a car which is in motion comes to rest. Change the speed and direction. A cricket batsman hitting a ball or gliding a ball. You just open the face of the bat. They say, right? Just opens the face of the bat and then glides down the ball for four. So you're changing the speed and direction. Right? Even the steering can also do this. The steering also acts as a force. It changes your direction of motion and change the shape and size. Can you give an example of this? Play-Doh, atta dough, or rolling a dough into a chapati. And if you think chapati is very desi, then you can say roll a pizza base. From dough to pizza. Right? Doors. When you open door every day, a door which is at rest, you are bringing it to motion. Yes or no? Push and pull. It again depends upon who is the applicant and from whose perspective you are seeing it. From whose perspective you are seeing it, right? Like you always talk to each other after seeing a horror movie. What do you say? Do you believe in ghosts? So what do ghosts speak to each other? Do you believe in men? Obviously. Ghosts will also speak with each other. No? Do you believe in men? Like you say, whatever it is. How do you know they can see it? Nowadays, ghosts are super afraid. So much of deforestation has happened. Ecological balance has been disturbed. Where do ghosts go? You have invented so many powerful lamps. Man is no more afraid at all. Earlier, he used to listen to ghost stories. Nowadays, he's only watching reels. Ghosts also have big targets now. Small kids, they are not with their grandparents. Nobody to tell them horror stories. Ours, the people used to say, like, oh, वहाँ में मत जाओ, झुझु आ जाएगा, बस यही better रहो. We never knew what is झुझु, but झुझु बोल दिया तो नहीं जाना है बस. So much of terror. I used to be very naughty. And I'm brought up in Assam, so it used to rain a lot. So when it rains, it becomes very dark. When it's in proper day at 10 o'clock, the outside light, ambient light would be like this. So much naughty I used to be that my mother used to always create fear of ghost stories and all these things. Otherwise, I'm not in control. And so much afraid I used to be that if I'm doing homework with her in a separate room, and suppose I need a sharpener, I have to go to that room to get the sharpener. I have to say, come and see. Then she will come. हाँ देख रहा हूँ जाओ. देख रहे हो तो हाँ 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 हाँ. Then only I'll get it. But nowadays children are not afraid. Phone. Now ghosts have a lot of problem. People themselves have so much of problem. Is this clear? So if you go in and see your textbooks, whether they are NCERT or whatever, there is a section which says up to characteristics or effects of force. Characteristics of force. Where you will see these characteristics. What are those? Rest to motion, motion. I would like to see that every one of you have made notes. Now you'll say, sir, how to make notes? I don't know. Notes are not something that I give to you. Notes are nothing that you give to me. Your notes are precious to you. How you maintain them? Your way. But I would like to see that you have prepared your notes. Your notes should have definitions. A lot of things we have discussed. So that it's a one-pager summary of whatever we have discussed. Very nice, very colorful. So that next time when you're reading it at that bus stand, you know that bus stand of ours? I call it DPD. DPD means, all the pet dogs are taken there. They will do potty and the dosa shop is out there. So I called it as DPD, doggy potty dosa. So near that doggy potty dosa, you will get, you can read your document. Vakul, you can ask Vakul. Vakul, you can ask Vakul. Vakul, sir had said about DPD. What is DPD? DPD is that shop. Doggy potty. All the doggies are out there. Okay. So you can take your, what you call, new note and you read your note. You don't need your textbook. Your note is so good to you and you make it. Not this. Today, this I call a scribble work. You have attended my class. Now prepare a fresh note up till this section. Whether you're following new book, whether you're following old book. And if you have no book, then Teams has the book uploaded. So prepare it up till here. Understood? Our next class will be talking about balanced and unbalanced forces. And then we'll talk about contact forces, non-contact forces. Every time the applicant and recipient need not have contact. Boyfriend rushes to girlfriend. There is no contact. Still, there is a force of attraction. Non-contactual. See, he has understood. We used to be like that in class. Sir, non-contactual force of love is also non-contactual. Child goes to his mother. So many calves are roaming on the street. Does every calf go to every cow? No. So sometimes we used to ask, how does this calf know that that cow is the mother of this calf? So when your mom goes to pick you up at school, how does she identify you amongst all children? The same way the cow also identifies his or her calf. Understood? So next day. And maths, I will now put a worksheet.
Take the fat one because mother needs it for studying.
Okay, you need the fat one? I'll give you. Le jao, usi room mein hai. You went to that room, right? You go to that room, the two fat books are there. Just get it. 2 blue books are there. Give one to her and you take one. कौन सा previous page? ये वाला. तो ये 4 characteristics याद रखना, ये बड़ा question आता है. Define force, or they will say what is the SI unit of force, and list down the characteristics of force. At that time, don't write your hand. Mila, did you get it? It's right on the plot. Yeah. Now he will see which one is more new. He will keep the more newer one. All are same.
Take the one with this hand.
Ah. So you can do problems from here. नहीं अभी तो क्लास खत्म हो जाएगा, ठीक है? So we'll close for today. And this, see, earlier children, whether you are following your school book of NCERT or any other book, an R.S. Agarwal or an R.D. Sharma are the best books. Why I have given you two? Because you two follow the old book. This is written to the old book. And others I have asked to buy the new book, which he has brought today. That one, which he has also brought today. So that book, mandatorily, you should do all problems. If you do only your NCERT, you will get marks also like NCERT. And if you are that guy who is happy with 60s and, you know, just to show crowd you play, ho gaya, 20 runs ho gaya na, ab 6 maro. And if you believe that you are a Virat Kohli, you can play a long innings, and please solve that book. ठीक है, चलिए.